We wish you would watch space weather. We wish you would watch space weather. We wish you would watch space weather. So here's some right now. Here's your 304 angstroms view. Small active region with a filament exploding out of it, which we did see yesterday also. This is 48 hours of the sun. No sunspots. See, that filament comes out like this. Let's zoom in on that. Probably just reattached to the sun. I didn't see it go flying off either of the sides. It was pretty high speed. And let's move on to other stuff. Stuff such as your magnetic lines, which have the sun looking strikingly like a jack-o'-lantern. An angry, demonic-looking jack-o'-lantern. Okay, enough of that. And let's look at spaceweathernews.com for some data, like a highly charged F2 ionosphere layer. X-ray flux is flatlined since yesterday. The BTBZ is really relaxing, really converging on the zero line there. No signal on the phi angle. Solar wind density extremely low, and we've seen a downtick in the solar wind speed. It looks like we're right around 500 kilometers per second now. Solar wind density must be like 2 protons per cubic centimeter. Magnetometer is looking smoother than it did yesterday. KP index is now at 2. Let's make sure this plays all the way through, so we have an easier time getting data in the future, just in case we need it. And let's analyze this too while we're at it. You can see we're dominated by negative charge here. And you can see that the heliospheric current sheet is well to the north of planet Earth. And we've been following this closely because of what's been going on with the magnetosphere for the past several days. And there's a bunch of people trying to crunch data. We requested some and we got it yesterday morning. This morning we analyzed it, and we'll show you a little bit about what went on with it, but I'll tell you right now, nothing conclusive happened. So, let that play through. Electron flux is leveling off. No prediction for that one. Now we can see as far as spacecraft charging hazards, not a whole lot going on there. And the F2 layer is actually heavily charged. Look at that, up to 13 megahertz. That's the highest we've seen it in, I want to say weeks. I think about a month. And the coffee's done. And the coffee's now in the French press, and we can get on with the update. So yeah, heavily charged here. There's your aurora forecasts. Let's look at the recent earthquake activity. You know, we had a 7.3 last night in Russia. No tsunami observed. Let's go back to that point. Near Bering Island. Here's your interactive map. Zoom out a little bit so you see the location. Largest earthquake in quite a long time. Fortunately, not too much damage because it was out in the Bering Sea. Since then, they had an aftershock. That took place about a half an hour later, it looks like. Another aftershock, 5.6. So that place continued to shake. They got really a swarm there, but it was all associated with that 7.3. There was also a 4.9 in the Central Atlantic Ridge. Another aftershock in Russia. Fiji experienced another deep 614-kilometer quake. Another aftershock in Russia, Papua New Guinea. I mean, those are real earthquakes too, by the way. Chile got a 4.5. Mexico got a 5.0. Indonesia 4.5. Lots of quakes in Russia. Another one in Papua New Guinea, New Caledonia. Take a look at the map so we can see that swarm. And there you have it, right on that plate boundary corner there. Now let's get to the main weirdness. Looking at the magnetosphere, which we've been doing for days, as there is an ongoing anomalous situation. Check out the angle of attack on the bow shock and the magnetotail. It's been consistently like that. And here's a video of this bizarre situation. We've got spots of extremely low pressure. Also see here. Our working theory is that it's caused by the heliospheric current sheet being so far to the north of the Earth. We've got several people looking into this who know more about it than we do. And let's just look at the velocity so that this is actually on the video also. Come on, you can do it. You can do it. And there's your velocity chart. There is an odd anomalous spike that happens back here. Very anomalous. It's not Nibiru. It's plasma. Moving on. Now let's look at magnetic perturbations on the surface. What we're seeing is large spillover of magnetic fields well away from the poles. Not intense magnetic fields, but, well, you'll see. Watch the Pacific Ocean. Fields reaching all the way down to Hawaii. Across the Indian Ocean, from the South Pole up to Australia. Let that play through one more time. Just blobs of magnetism all over the Earth. All around the realm of like 50 nanotesla. Not huge, but a little bit anomalous. And let's look at the same thing from the perspective of the poles. Be able to see how the fields kind of bleed out. And there's your magnetic perturbations at the poles. Let's put it to the current spot. There's the current situation. Now, since we have been looking at the magnetosphere and hypothesizing that it's the heliospheric current sheet that's causing it to be so shifted, we would like to direct you to our channel, youtube.com/smashomash. One of our officially endorsed channels is the Starman. Last I checked, he was actually looking into this magnetosphere situation. So we recommend that you go to his videos, scroll down, and watch this video on the heliospheric current sheet. Here's a little snippet.
So let's have a look at the high-speed solar wind. So we look at the solar wind after the period of 2002. We've seen a sharp increase in solar wind up until around about late 2004.
Now let's show you your planetary locations. Great planet map here at Planets Today, theplanetstoday.com. And Earth is approaching a Saturn opposition. Check it out. Let's look at some Earth weather. As we're getting inundated in eastern Pennsylvania right now, and indeed, the entire East Coast is getting hammered with rain. We got some snow coming down here. And there is some thunder and lightning. And here's your NASA GOES water vapor map. Point of interest here, well, two really. One, we've got this atmospheric river coming up here. But more interestingly than that, see this U shape? That, viewers, is the jet stream traveling due south and then due north again, with only about 200 miles in between. That is meridional jet stream flow at its finest, and that is why it is so warm on the East Coast right now. As we've said before, meridional jet stream flow as opposed to zonal jet stream flow absolutely pulls hot air out of the equatorial regions and cold air out of the poles and puts it in places where you wouldn't expect it to be. It's not global warming, it's the sun and the Earth's magnetosphere. Let's look at tropical tidbits so you can see the situation here. So here on tropical tidbits, you can see the 250 millibar upper level winds here. There's your jet stream meridional flow. Look at that, almost due south, almost due north. The jet stream usually flows like this, folks, for those of you who aren't aware. The jet stream is usually like this. The jet stream is not usually like this. And it doesn't usually break into pieces so much. Now let's look at a silly article about dark matter on phys.org. Now, for those of you who are not aware, the standard cosmological model states that we can't see 95% of the matter in the universe because we don't understand gravity's effects, especially at the galactic scale. These things are controlled by electromagnetic fields and not gravity, and that is why everybody's clamoring for dark matter. Now, we'd just like to say one more thing about dark matter, that it doesn't exist, but the quest for dark matter may not be a completely bad endeavor because it may inform us of where the fields that do control the motions of these things are located. So perhaps in the future, once we really understand the physics, we'll be able to take the dark matter data and figure out what parts of the universe are being hidden by magnetic fields. Now remember, if you're looking at an object behind this star here, magnetic fields are absolutely going to affect what you're seeing on the other side. And if you're trying to look closely at something, as we see every day with the sun, magnetic fields mask other magnetic fields as well as interact with them. They're basically opaque. And that's why voids are such an interesting part of the universe. We'll cover that later. Let's look at another phys.org article, and by the way, we will leave links to all of these. Talking about the black hole singularity. Looks exactly like Primer fields to me, but I guess maybe this is the spot here where, you enter another dimension. The problem is, well, I'll just read this whole paragraph. The bottom half of the image depicts the black hole, which we refer to as a massive radio source. According to general relativity, we're not going to get into those weeds, traps everything including light. Effects based on loop quantum gravity, a theory that extends Einstein's general relativity using quantum mechanics to overcome this tremendous pull and liberate everything, the top half of the image, thus providing a concrete avenue for recovery of information previously thought to be lost in the black hole singularity. Sounds like they're having problems with their own math, folks. Anyway, we'll leave links to the article below because we got to get moving because there's more stuff to cover. Now, we haven't been too pleased with Facebook lately, and it turns out that nobody's too pleased with Facebook lately. For those of you who aren't aware, we got banned last week from posting to Facebook groups or joining Facebook groups, although for some reason it's still letting us administer the Facebook groups, so figure that one out. And when we got unbanned, the first video we tried to post, we got it into, I think, 2 of our groups, and then we got rebanned. Now, we appealed to both of these, and we received no response. We also received no warning and no explanation of why we were banned. Other than we violated community guidelines, I guess by doing daily science videos. Sorry, Facebook. Geez, we didn't mean to offend. Sorry about those billions of dollars you lost, Mark. You chump. Guess what Zero Hedge says? Facebook has officially lost the public's trust. So big tech, right? Yeah, we don't trust big tech. I mean, Amazon, Twitter, Google, Netflix. I mean, how are you going to trust big tech? Well, it turns out 5 times as many people don't trust Facebook as Twitter or Amazon. And, yeah, more than that. Sorry about your stock price, Facebook. Maybe you shouldn't ban legitimate stuff. Maybe you should, I don't know, provide explanations as to what's going on. Poor Mark, he looks so sad. Let's talk about our favorite cosmic ray source, Cygnus X3. See that? The swan's tail. Deneb, otherwise known as Cygnus X3. It's one of the odder objects in our galaxy. And you're looking right down the barrel of it when you look at this thing. By the way, this circles the North Pole, and at the other end of the precessional cycle is the North Pole. Ancient societies seem to believe this could be like, the bringer of life, the progenitor. This gives rise to tales of the stork carrying babies. And for some reason, this is where you go back when you go back to the sky world, aka die. Why are we talking about it? Well, because to quote Pierre-Marie Robitaille, we live in a universe of light, not of darkness. And if you don't think you're connected to everything out there, you got another thing coming. Now, what is this? This is a combination of X-ray and radio source images. Now, you can see this red spot, and you can see this blue blob, which actually looks like a bird in flight, shockingly. How ancient people 12,000 years ago associated this with a swan, we have no idea. Could probably just be a coincidence. But maybe humans had high technology millions of years ago. Kind of hard to say. How long does it take an ape to lose his hair, though? In any case, the blue blob is a jet coming out of this massive object pointing right at you. And that red object, well, that's the other end of the jet pointing away from you. Red shifted light versus blue shifted light. And this object here is what we call a Wolf-Rayet star, which is being eaten by this object here, a massive radio source People call it a quasar, a blazar, a neutron star, a quark star. We'll just call it a massive radio source. Here's an artist's rendition. By the way, this massive radio source appears to be eating this star. One of these jets is pointed right at Earth, and the other one appears to be giving birth to a new star. So it's a binary system becoming a trinary system, perhaps. Probably condensing on an ionization path at the other end of the jet. Super interesting stuff. Cygnus X3. By the way, this is the brightest single object visible from Earth. I'm not exactly sure how far away. I believe the current estimate is about 1,200 to 1,600 light years. It's very hard to measure it because we are looking right down the Z-pinch effect of this jet. It is also believed that this thing rotates around this star at a period of roughly 4.8 hours. And when it does so, it sends cosmic rays each time it comes out from behind this Wolf-Rayet star. How do we know? Well, because if you live in the northern hemisphere, they've been going through your head and the rest of your body, and thousands of feet of rock, and indeed half of the planet, if not all of the planet, your entire life. And for thousands, if not millions, if not billions of years. Please don't forget to like and subscribe to videos if you enjoy our content. Normally we close our videos out with an image of the sun, but right now we find this a little more interesting because this is happening in our backyard. We're going to let that play through for a minute here. Let it play through a few cycles. By the way, all our original is music. Let's try that again. We don't do editing here. All our music is original. Thanks for tuning in, and remember, on your way studying the magnetosphere, don't drink. And if you drink, study the magnetosphere, because it's looking quite odd and anomalous.